Okay, last but not least, problems 13 through 15, and these are, I think, more difficult SAT problems, or at least require a different way of looking at it. We're solving for x here, and if we look at this, if x equals, oh my God, x to the 3/4 power, that equals 27. What's the value of x? It seems tricky, right? You could probably guess and check this, but you'd be spending all day at a calculator doing that, unless you have really good number sense. So before I get into 13, I want to do something very basic first. Because if you can see what's going on in this basic problem, you'll understand that the rules of math work with basic stuff and way more complex things. If you see the algorithm here, you'll see that I'm doing a trick in the problem to solve for x. Because I have a goal in mind, and I'll apply the rules of math with that goal in mind. So no more beating around the bush. Let's do a quick review, though. What is 2 cubed? All right. Well, 2 cubed means take the base and multiply it by itself 3 times. So 2 cubed is really 2 times itself 3 times, and that's 4, and then 4 times 2 is 8. All right. 2 cubed is, in fact, 8. Okay. Now, when I have this equal sign, okay, it's saying what's on the left side is identical to what's on the right side. So if I'm going to preserve equality, whatever I do to one side of my equal sign, I must do to the other side, right? I have to treat both sides equally. So I want to know, when I square 8, how does that affect my left side? All right? I want to know, like, the point of this problem is to see what's going on when we raise a power to a power. Okay? I'm going to use this example to show you. I can do 8 squared very easily. 8 squared is simply 64. It's 8 times itself, 64. Here, though, this is a little bit more complicated. Yeah, the way I would do it, the way you normally do it, if you were just trying to solve 2 to the cubed and squared, yeah, you do what's in the parentheses, right? Yeah, we already know 2 cubed is 8, and then it becomes 8 squared, which is that 64. But that's not the point of this problem. I want to show you that there's something going on. There's a rule that can be applied to any type of problem. And I'll use the rule and convince you. So when you raise a power to another power, so 3 getting raised to a second power, you multiply them. It's the product, right? You're going to keep your base of 2, and then you're going to rewrite it as a single power. And the rule is you multiply your powers. So 3 times 2 is 6. So I'm making the claim that 2 cubed, then squared, right? 2 cubed and then squared, we know equals 64, right? You can see that logic up there. But I'm telling you, that's really a different, it's another way to look at it is 2 raised to the 6th power. And if I'll show you that these are in fact the same, okay? Because 2 to the 6 is 2 times 2 times 2 times 2 times 2 times 2. It's 2 times itself, 1, 2, 3, 4, 5, 6 times. All right, and if this does in fact equal 64, right? Let's see. 2 times 2 is 4. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. Well, 4 times. Oh, look at that. 2 to the 6th power does in fact equal 64, verifying that this rule is correct. That whenever you have a power raised to another power, the rule is multiply the powers. And you'll see why that's useful here. In this problem, I have x raised to the 3/4 power equal to 27. And they say, what is x? Right? What is x equal to? All right? So over here, I want to know what this number is. Notice the power on x is a hidden 1. Okay? And I know when I raise a power to another power, the interaction, right, the thing that goes on between them is multiplication. So if I wanted to solve for x, if I wanted to get rid of this 3/4, it becomes a problem of, well, what would I have to multiply 3/4 by to get 1? I'm playing a trick. Because if I can get rid of this 3/4, whatever I do, watch. What times 3/4 will give me 1? The reciprocal. Whenever you have a fraction, it's the reciprocal, all right? So 4/3, the reciprocal of my power. Well, if I'm raising the left side to 4/3 power, I got to do the same thing to my right side, all right? So this interaction, 3 times 4 is 12, and 4 times 3 is 12, and 12/12, right? 12/12. This is now 27 raised to the 4/3 power. 12/12 is 1, so this is now x. So x equals this. I just have to simplify that, right? And it's saying when it's a fraction, it's radical, and then my numerator goes here, and then it's the cube root, okay? And I can evaluate this, whichever one I want first. I can take my radicand, the thing under the radical, and I can raise to the 4th power, and then cube root it, or I can cube root it and then raise it to the 4th. And I know 27, that's going to be hot all the time. 27 is a cube. It's a perfect cube. The cube root of 27, what number times itself gives you 27? That's 3. So this is really 3 to the 4th power, right? The cube root of 27 is 3. Now all I have to deal with is raise to the 4th power, okay? So 3 to the 4th power is very manageable. It's 3 times itself, 4 times. That's 9. This is 9. It's really 9 times 9. It's really 81. So when x is 81, that's when x to the 3/4 is 27. And I'll show you that here. Let me pull out my calculator. And I'm making the claim that x has to be 81. So I'm saying take 81, and I want you to raise that to the 3/4 power. And yeah, there's the 27, right? There's the 27 that I was looking for. So 81, right? 81 is the value of x that when I raise to the 3/4 power gives me 27. And I'm doing this by doing a trick. I'm making my power into 12/12 into 1. And I know whatever I do to one side, if I raise the left side by 4/3 to accomplish this, to get my left side to an exponent of 1, then I have to do the same thing to the other side. And that's the trick of this problem. So instead of clumping 13, 14, and 15 into one video, I'm going to separate them. 13 will be its own video.